Hello guys! We are now on the second type of conic sections, the parabolas. In today's lesson, I would like to be able to define parabolas by defining its characteristics, determine the standard form of the equation of a parabola through mathematical reasoning, solve situational problems involving parabolas, and demonstrate patience, determination, and critical thinking in understanding the key concepts of parabolas to help in solving concerns in science, technology development, and engineering in order to contribute to the country's economic development. I hope this recorded discussion will help you understand further what parabolas are. But before we proceed to the discussion on parabolas, I would like to challenge everyone through this question: how can you use your knowledge in uplifting our country's economy? I hope you would be able to answer this question after our discussion. Are you familiar with the game flash on the screen? You're correct. The game is entitled The Angry Birds. Do you know why the birds are angry? The pigs have stolen the birds' eggs, so they're angry. The birds are on a quest to get them back. They accomplish this by launching themselves, or rather, having you launch them from slingshots and catapults into the pigs' fortresses, knocking them down. The game may seem silly and simple, but do you know that Angry Birds has been downloaded over 500 million times? And that 80% of people who download Angry Birds keep the app installed? That the latest game in the series, Angry Birds Space, was downloaded more than 20 million times in the first week of its release? And that, globally, people play Angry Birds for 200 million minutes each day. But you're wondering, how is this game related to our topic for today, the parabolas? Observe how the birds move in order to hit the pig. Yes, the bird's movement or motion is parabolic in nature. Let's say the Angry Birds is at a point with coordinates -1, 5, and the pig is down below with coordinates 7, -3. There can be many ways in order to hit the pig with the given coordinates, but can you find the equation of one of the parabolic paths which the Angry Bird can take in order to hit the pig? But before you answer that, allow me to discuss the rudiments of parabolas. Let us define the word parabola. A parabola is the set of all coplanar points which are equidistant from a fixed point and a fixed line. With this definition, it means that a parabola lies on a single plane. The fixed line is called the directrix, while the fixed point is called the focus. The point that is directly in between the directrix and the focus is the vertex of the parabola. The vertex is the turning point of the parabola. The line that passes through the focus and the vertex is called the axis of symmetry. The axis of symmetry divides the parabola into two equal parts. The segment that is parallel to the directrix and that passes through the focus is called the latus rectum. The ratio of the distance of a point to the directrix and to the focus is called the eccentricity. The parabola's eccentricity is always 1. We can write the equation of a parabola in two forms. The first form is the general form, and the second form is the standard form or the vertex form. Let's consider a parabola having an axis of symmetry parallel to the x-axis. It means that the parabola opens sideways. If the parabola opens sideways, its equation is given by y squared plus bx plus dy plus e equals 0. Consider the given equation. Y squared minus 4x minus 4y plus 8 equals 0. Using Desmos, we would be able to get a graph having a vertex at 1, 2, focus at 2, 2, the length of latus rectum is 4 units, and its endpoints is at 2, 4, and the other is at 2, 0. Getting the difference between the ordinates of the endpoints of the latus rectum, 4 minus 0, the difference is 4. Confirming our answer a while ago that the length of the latus rectum is 4 units. Can you see the purple line that passes through the vertex 1, 2 and the focus 2, 2? That is the axis of symmetry of the graph, and its equation is y equals 2. On the other hand, the directrix of the parabola is a vertical line with an equation of x equals 0. The centricity of a parabola is always 1. But let us explore whether it's really equal to 1. Consider the point 2, 4. We get the distance of this point from the directrix. Okay, we count 1, 2. Getting the distance of this point from the focus, we will get 1, 2. Remember that to get the centricity of a curve, especially the conic section, we get the ratio of the distances. In other words, the centricity of this parabola is 2 over 2. When simplified, will give you 1. We are now confident that the centricity of any parabola is equal to 1. Do you notice that the graph passes through the x-axis? We can say that the point 2, 0 is the point of intersection of the graph and the x-axis. In other words, the x-intercept of the graph is at 2, 0. Can you see a point of intersection between the y-axis and the graph? Of course, there is none. In other words, we can say that the graph has no y-intercept since it does not pass through the y-axis. Probably for now you're wondering, how did we get these pertinent details about the given parabola? Just relax. We will discuss that further in the next succeeding slide. But for now, let us discuss how parabola look like and its equation. This time, let's have a parabola with axis of symmetry parallel to the y-axis, or what we call the regular parabola. Take note that this kind of parabola may open upward or downward. And its equation is given by x squared plus bx plus dy plus e equals 0. Let's consider the given equation. X squared plus 2x minus y plus 3 halves equals 0. Using Desmos, we would be able to graph this parabola with vertex at -1, 0.5 or 5/10 and focus at -1, 0.75 or 75/100. The length of its latus rectum is 1 unit, and its endpoints are at -1.5, 0.75, and -0.5, 0.75. Just like what we did in the first example, to confirm whether the length of the latus rectum is really 1 unit, we will get the difference. This time, we get the difference between the abscissa of the coordinates of the endpoints of the latus rectum. In that case, we will have -1.5 minus -0.5 will give you -1. But since we are dealing with distance, we will get the absolute value of -1, which, when simplified, will give you 1 unit, thus confirming our answer that the length of the latus rectum is 1 unit. The axis of symmetry is found at x equals -1. It is the vertical line that passes through the vertex and the focus. The directrix is given by the equation y equals 0.25. Notice that the distance of the directrix from the vertex and the distance of the focus from the vertex are the same. Do you notice that this graph passes through the y-axis? And that is the point 0, 1.5. We say that the y-intercept of this graph is at 0, 1.5. Since this graph does not pass through the x-axis, we say that there is no x-intercept. Let us proceed to the second form of an equation of a parabola, the standard form or the vertex form of an equation of a parabola. Let us first consider a parabola with axis of symmetry parallel to the x-axis. As we have discussed a while ago, that when the axis of symmetry is parallel to the x-axis, the parabola opens sideways. When the parabola opens to the right, its equation is given by the square of y minus k equals 4c times the quantity x minus h. On the other hand, when the parabola opens to the left, its equation is given by the square of y minus k equals -4c times the quantity x minus h. For example, we have the equation the square of y minus 2 equals 4 times the quantity x minus 1. In this equation, we can easily determine the coordinates of the vertex. In this case, h is equal to 1, while k is equal to 2. Therefore, we can say that the coordinates of the vertex is 2, 1. To tell whether the parabola opens to the right or to the left, we check on the value of c. We can also determine whether it opens to the right or to the left using the graph. But what if we do not have the graph yet? How can we determine whether it opens to the right or to the left? Take a look at the value before the quantity of the linear term. In this case, we have 4. It means that 4c is equal to 4. Dividing both sides by 4, we will get the value of c, which is equal to 1. Take note that c is the distance between the focus and the vertex. In this graph, we can say that the distance of the vertex and the focus is equal to 1. We also take note that the distance between the vertex and the directrix is just the same as the distance between the vertex and the focus. In this particular example, since c is equal to 1, we can say that the distance of the vertex from its directrix is equal to 1. Thus, we can have the following details. The vertex is at 1, 2. The focus is at 2, 2. The length of the latus rectum is 4 units. We may count the distance between the points 2, 4 and 2, 0, or we can subtract the ordinates 4 and 0 in order to get the length of the latus rectum, which is 4 units. The axis of symmetry, take note, is the line that passes through the focus and the vertex. So in this case, we have y equals 2. Its directrix is x equals 0, since the distance of the directrix and the vertex is equal to the distance of the focus and the vertex. Hence, we will have x equals 0. The graph passes through the x-intercept, so we can say that the intercept or the x-intercept is 2, 0. However, the graph does not pass through the y-axis. Therefore, we can say that the y-intercept does not exist, or there is no y-intercept. Let us consider a parabola with axis of symmetry parallel to the y-axis. Based on our discussion a while ago, we can say that this parabola is a parabola that may open upward or downward. When the parabola opens upward, its equation is given by the square of x minus h equals 4c times the quantity y minus k. When the parabola opens downward, its equation is given by the square of x minus h equals negative 4c times the quantity y minus k. Let us consider the given equation. Y minus 1/2 equals the square of x plus 1, or the square of x plus 1 is equal to y minus 1/2. Using Desmos, we would be able to graph the given equation. But before that, let us rewrite the given equation using the given format. The square of x minus h equals 4cy times the quantity y minus k. Since there is no numerical coefficient or no number before y, we can say that the numerical coefficient of y is 1. Thus, extracting the common factor 1, we would be able to get the equation the square of x plus 1 equals 1 times the quantity y minus 1/2. Hence, we can say that 4c is equal to 1. Dividing both sides by 4, c is equal to 1/4, or in decimal form, it is equal to 0.25. Note that C is the distance between the focus and the vertex, or the distance of the vertex and the directrix. To get the coordinates of the focus, we add the value of C to the ordinates of the vertex. Thus, we will get -1, 0.75 as the coordinates of the focus. To get the length of the latus rectum, we determine 2 points which are collinear to the focus. Therefore, we can get -1.5, 0.75, and -0.5, 0.75. This will be the endpoints of the latus rectum. To get the length of the latus rectum, we subtract the abscissas of the coordinates of the endpoints of the latus rectum, giving us -1.5 minus -0.5 equals to -1. But since we are dealing with distance, we get the absolute value of -1. Simplifying, we will get 1 unit. Therefore, we say that the length of the latus rectum is 1 unit. Remember that the axis of symmetry is the line that passes through the vertex and the focus. And that line is given by the equation x equals -1. To get the equation of the directrix, we go back to the definition or to the description of the value of C. That C is the distance between the focus and the vertex, or the vertex and directrix. To get the equation of the directrix, we subtract 0.25 from the ordinates of the vertex. Thus, we have 0.5 minus 0.25, giving us 0.25. We say that the equation of the directrix is y equals 0.25. Does the graph pass through the x-axis? You're correct. The graph does not pass through the x-axis. Hence, we can say that the graph has no x-intercept. On the other hand, we say that the graph passes through the y-axis. Therefore, its x-intercept is 0, 1.5. Take note that this is the point common to the graph and the y-axis. Notice that when the equation is in the standard form or the vertex form, it is easy to write or to determine the pertinent details about the parabola. In the previous examples, we have a parabola with vertex at hk. This time, let us study the parabola with vertex at the origin. Always remember that the coordinates of the origin is 0, 0. If we have a parabola with axis of symmetry parallel to the x-axis, or in other words, the parabola opens sideways, its equation is given by y squared plus bx equals 0. we may sketch the graph of the given parabola. It may open to the right or to the left. When the parabola opens to the right, the coordinates of the focus is given by c, 0. Its directrix is given by the equation x equals -c. On the other hand, when the parabola opens to the left, the coordinates is at, or the focus is at -c, 0, while the directrix is given by the equation x equals c. For example, we have y squared plus 2x equals 0. Using Desmos, we can graph the given parabola. The vertex will be at 0, 0, which is the origin. The focus will be at -0.5, 0. While the length of the latus rectum is 2 units, its endpoints is -0.51 and -0.5, -1. The axis of symmetry is y equals 0, while its directrix is x equals 0.5. Since it passes through the x and y axis at 0, 0, the graph has x-intercept and a y-intercept, which is the vertex itself. Now, what about if we have a parabola that opens upward or downward? Its equation is given by x squared plus dy equals 0. Take a look at the coordinates of the focus, the vertex, and the equation of the directrix. For a parabola that opens upward, the coordinates of the focus is at 0, c, while the equation of the directrix is given by y equals -c. For a parabola that opens downward, the focus is at 0, -c, while the directrix is given by the equation y equals c. Now let us consider the parabola with equation x squared minus 4y equals 0. Graphing it using Desmos, take note that its vertex lie at the origin. Its focus is at 0, 1. The endpoints of the latus rectum is at -2, 1 and 2, 1. Getting the difference between the abscissas of the coordinates of the endpoints, we would be able to get the length of latus rectum, which is 4 units. To get the equation of the directrix, we will just subtract 1 unit from the ordinate of the vertex, 0 minus 1. We will get y equals -1. Again, since this graph passes through the x and y axis at the origin, the x-intercept and the y-intercept is the origin itself. In the previous examples, we noticed that writing the given equation in standard form or vertex form will lead us to determining the pertinent details of a parabola. By determining the value of c, we would be able to determine the coordinates of the focus, the equation of the directrix, and so on. So in this case, Let us transform the given equation to this format: y squared equals 4cx or y squared equals negative 4cx. For example, we have y squared plus 2x equals 0. Transposing the linear term to the other side, we will have y squared equals negative 2x. To find the value of c, we equate negative 4c equals negative 2. Dividing both sides by negative 4, we will get c equals 0.5. Hence, we can say that the vertex is at 0, 0. Focus is at negative 0.50 since the parabola opens to the left. For the length of the latus rectum, we just get the absolute value of 4c, which is the absolute value of negative 2. In order to get the coordinates of the endpoints, we will add or deduct 1 unit to the coordinates or to the ordinates of the focus, which is 0. Adding 1 to 0, we will have 1. Deducting 1 from 0, we will have negative 1. Hence, the endpoints of the latus rectum will be at negative 0.51 and negative 0.5, negative 1. Graphing this using Desmos, we would be able to illustrate the graph of y squared equals negative 2x. Now, what if we have the parabola with a given equation x squared minus 4y equals 0? Are we going to do the same? Yes, we will have to transform the given equation to this form: x squared equals 4cy or x squared equals negative 4cy. Transposing the linear term to the other side, we will have x squared equals 4y. We can say that 4c equals 4. Dividing both sides by 4, we will have c equals 1. Now we are ready to determine the coordinates of the focus. From the vertex, which is 0, 0, we add 1 or we count 1 unit upward since the parabola opens upward. We will get the coordinates of the focus, which is at 0, 1. For the length of the latus rectum, we just get the absolute value of 4c, which is the absolute value of 4. When simplified, will give us 4 units. To get the coordinates of the endpoints, we divide 4 by 2. That will be the number of units to be added or subtracted to the abscissas of the focus. So we will have endpoints of latus rectum negative 2, 1 and 2, 1. Graphing the parabola, we would be able to have a clear view of these details. Take note that the directrix is at y equals negative 1, which is 1 unit down below the vertex. Notice that the focus is 1 unit above the vertex. And the endpoints of the latus rectum is collinear or are collinear to the focus of the parabola. We can say that the axis of symmetry of the given parabola is the y-axis, which is described by the equation x equals 0. Don't forget, the given equation can be summarized using this table. When the parabola has vertex at the origin, take note that we have 4 possible forms of equation. It can be x squared equals 4cy with focus at 0c, directrix at y equals negative c, latus rectum of 4c, and axis of symmetry x equals 0. Well, if we have a parabola that opens downward, we will have x squared equals negative 4cy with focus 0, negative c, equation of the directrix y equals c, while for the lattice rectum we will still have 4c, and axis of symmetry x equals 0. For parabolas that open sideways, we will have y squared equals 4cx for parabola that opens to the right. This kind of parabola will have a focus at c0 with directrix x equals negative c, length of lattice rectum 4c, and axis of symmetry y equals 0. For the parabola that opens to the left, we will have y squared equals negative 4cx. In this case, the focus will have coordinates negative c, 0. The equation of the directrix is y equals c. The length of the latus rectum is 4c, and the equation of the axis of symmetry is y equals 0. Here is also a table summarizing a parabola with vertex at hk. When the parabola is regular, we can determine whether it opens upward or downward using the value of c. If c is greater than 0, or c is equal to a positive number, we can say that the parabola opens upward. The coordinates of the focus is at hk plus c, which is above the vertex. The directrix is given by the equation y equals k minus c, and the axis of symmetry of the parabola is x equals h. When c is negative, or c is less than 0, the parabola opens downward. Its coordinates, or the coordinates of the focus, is given by h k minus c, which is below the vertex. Directrix is given by the equation y equals k plus c, and the axis of symmetry of the parabola is given by x equals h. On the other hand, when the parabola opens sideways, we can also use the value of c. When c is greater than 0 or equal to a positive number, the parabola opens to the right. The coordinates of the focus is at k plus c, k, which is to the right of the vertex. Its directrix is given by the equation x equals h minus c, and the axis of the parabola is at y equals k. Lastly, when the value of c is less than 0, or c is equal to a negative number, the parabola opens to the left. The coordinates of the focus is h minus c, k, which is to the left of the vertex. Its directrix is given by the equation x equals h plus c, and the axis of symmetry of the parabola is given by the equation y equals k. Always remember this, because when you master this format, everything will be much easier. We have observed that it's much easier to get the coordinates of the focus, the equation of the directrix, the length of the latus rectum, when the equation is written in the standard form or in the vertex form. So at this point, we will study how to transform equations of parabolas from general form to standard form. In the previous lesson, we used acronym in transforming equations. Can you also think of an acronym which will give us the steps on how to transform equations of parabolas from general form to standard form? Let's see. Let's consider y squared plus 4y plus 16x plus 20 equals 0. Let's start with letter S. Separate the terms having the same variable as the quadratic term. We place at the left side of the equation the terms having the quadratic term, while all the other terms are at the right. Doing that, we will have y squared plus 4y equals negative 16x minus 20. The second step is to add to both sides a constant which will make the binomial with the quadratic term a perfect square trinomial. In other words, we have to make y squared plus 4y a perfect square trinomial. How do we do that? We get 4 divided by 2, then square it. So 4 divided by 2 is 2. Square that, we will have 4. Hence, we will add 4 to both sides of the equation to maintain equality. The third step is to factor out the perfect square trinomial and simplify the other side of the equation. Factoring out y squared plus 4y plus 4, we will get the square of y plus 2. And on the right side, simplifying negative 20 plus 4, we will have negative 16. Hence, on the right side, we will have negative 16x minus 16. The last step is to extract the greatest common factor of the binomials at the right. We note that negative 16 is common to the two terms. Extracting negative 16 from negative 16x, we will get x, while negative 16 divided by negative 16, we will get 1. So, the standard form of the given equation is the square of y plus 2 equals negative 16 times the quantity x plus 1. Take note, it's very easy to identify the value of c in this case. So 4c is equal to negative 16. So hence, we will have a negative value for c. Or if we have negative 4c equals negative 16, we will have c equals positive, then we will just follow the format given, whether it's opening upward or downward. Okay, remember, to reach our goal, keep safe. Let's take a look at the second example. Y squared minus 4x minus 4y plus 8 equals 4. Doing the first step, we separate all the variable or all the terms with variable y from the variables from the terms having other variables. So we will have y squared minus 4y at the left and 4x minus 8 at the right. Now we complete the binomial to make it a perfect square trinomial. We get 4 divided by 2 is 2. Square that, we will get 4. So the constant to be added to both sides is 4. Oh, don't make a conclusion that it is always 4. It is always 4, or we will always add 4 in order to get a perfect square. No, it's just a coincidence. Okay, the next step is to factor out the given trinomial. So that is equal to the square of y minus 2. On the other hand, or on the other side, we will have negative 8 plus 4. Combining that, we will have negative 4. So at the right side, we will have 4x minus 4. For the last step, we extract the common factor of the expressions at the right. So we will have 4x minus 4, that is, the common factor is 4. So 4x divided by 4 is x, negative 4 divided by 4 is negative 1. Therefore, the standard form of the given equation is the square of y minus 2 equals 4 times x minus 1. From this equation, we would be able to get force equals 4, following the formula. In order to get c, we have to divide both sides by 4, so c is equal to 1. Now, using the value of c, we would be able to get the coordinates of the focus. Okay, from the vertex, we have 1, 2. We add 1 unit to the abscissa of the vertex. So 1 plus 1, we will get 2. We just copy the ordinates of the vertex to get the ordinates of the focus. So in other words, we will have focus at 2, 2. Now, to get the equation of the directrix, take note, we have c equals 1. From the vertex, we deduct from the abscissa of the vertex 1, so 1 minus 1, we will have 0. Therefore, the equation of the directrix is x equals 0. Now, to get the length of the latus rectum, we just get the absolute value of 4c, which is equal to 4. Hence, we will have 4 units for the length of the latus rectum. We divide that 4 units by 2. We will get 2. Now, in order to get the endpoints of the latus rectum, from the focus, we add 2 units to the ordinates to get one of the endpoints. So 2 plus 2, 4. So one of the endpoints will be 2, 4. Now, to get the other endpoint, we subtract 2 units from the ordinate. So 2 minus 2 equals 0. Hence, the other endpoint of the latus rectum is at 2, 0. Now, to get the equation of the axis of symmetry, we just get the ordinates of the focus. So y equals 2. Now we can say that there is an x-intercept if the graph passes through the x-axis. Without looking at the graph, how can we determine the x-intercept? We can just make y equal to 0. So if we will have y equals 0, then we will have an equation negative 4x plus 8 equals 0. Doing mathematical manipulations, we will get x equals 2. So therefore, when y is 0, x equals 2. The x-intercept of the given graph is at 2, 0. Now, can we determine the y-intercept without graphing? Yes, of course. We can just equate x equals to 0. Now, if we equate x is equal to 0, we will have y squared minus 4y plus 8. This trinomial is not factorable, so therefore, the graph will not pass through the y-axis. Hence, we can say that there is no y-intercept. In the third example, we will have x squared plus 2x minus y plus 3 halves equals 0. Take note, this is the second example a while ago. Now, we do the first step, separate the variables or separate the terms with the variables having the quadratic term. So the quadratic term is x squared. So we group the terms having x's, and all the other terms will be written at the right. So we will have x squared plus 2x at the left side, while y minus 3 halves at the right side. Now we complete the given binomial. So 2 divided by 2 is 1. Square that, we will get 1. We add 1 to both sides. Then we factor out the given trinomial. So we will have the square of x plus 1. On the other side, we will have negative 3 halves plus 1. Simplifying that, we will have negative 1 half. Is there a common factor in the expressions to the right? Yes, there is. The common factor is 1. So we can extract that in order to have a clear view that 4c is equal to 1. Okay. So in this case, c is equal to 1 over 4. Applying the same technique as in the previous example. Okay, vertex is at negative 1, 0.5. In order to determine the focus, in order to determine the coordinates of the focus, we will add 1/4 or 0.25 to the ordinates of the vertex. Hence, we will get the coordinates of the focus, negative 1, 0.75. Now take note that 4c is equal to 1, so therefore the length of the latus rectum is equal to 1 unit. Now to get the endpoints of the given parabola, or to get the endpoints of the latus rectum of the given parabola, we will add 1 to the abscissa, okay, to the abscissa of, we divide 1 unit by 2, so the result is 0.5. So all we have to do is to add 0.5 to the abscissa of the focus, so negative 1 plus 0.5, we will have negative 0.5. While if we will add or subtract negative 0.5, we will have negative 1.5. Hence, the endpoints would be negative 1.5, 0.75, and negative 0.5, 0.75. The axis of symmetry will have an equation of x equals negative 1, and the directrix will be y equals 0.25. Equating x equals 0, we would be able to get the y-intercept, which is at 0, 1.5. Now you have learned how to write equations of parabolas in standard form. Let's go back to the problem that I have given you. How can we determine an equation of one of the parabolic paths of the angry birds in order to hit the pig at 7, negative 3? We recall the standard form or the vertex form of parabolas. In this case, the parabolic paths of the angry bird is a parabola that opens downward. Hence, we will have to consider the format of the equation, the square of x minus h equals negative 4c y minus k. Now, looking at the graph, we will have to assume a vertex in order to get the equation of the parabola. particularly the value of c. So in this case, we will use 1, 6, and I'll choose the point 7, -3. Using the vertex at 1, 6 and a point at 7, -3, we would be able to get the value of c. We substitute the value of the value of the variables. So x is 7, h is 1. Now y is -3, while k is 6. So we replace that with the values of the given variable. So simplifying, we will have 7 minus 1 is 6. Then -4c times quantity, -9. Multiplying that, we will have 36. On the other side, we will have -4c times -9, which when simplified will give you 36 equals 36. Hence, we will have c equals 1. That is, by dividing the given equation by 36. So again, we were able to get the value of c, which is equal to 1. Now supplying the given or the found value of c to the given format, okay, we will have, again, h equals 1, we will have k equals 6, then c is equal to 1. So we replace that, the variable with the known values. Okay, simplifying further, we will have the square of x minus 1 equals -4 times the quantity y minus 6. Are we done? Yes. We can check whether we have found the correct equation of the parabola. We can check using the vertex 1, 6 and the coordinates of the other point, which is -1, 5. After substituting to the given format, we will get -1 minus 1 raised to the second power and -4 times 5 minus 6. Simplifying that, we will have -2 raised to the second power at the left, and we have -4 times -1 at the right. Simplifying further, we were able to prove that 4 equals 4, or we were able to prove that the left side is equal to the right side. Now, let us go back to the challenge that I have given you. How can you use your knowledge in uplifting our country's economy? In the subject orientation module, you have answered that, or I was able to find out that some of you would like to become a pilot. Take a look at the motion or the movement of an airplane taking off. Can you imagine the path that will be taken by the airplane from takeoff to landing? Yes, it is a parabola. It is a parabola. Or you can say that the airplane will follow a parabolic path, just like the Angry Bird in the game that we have. Now let me check. Were you able to define parabolas? Were you able to determine the standard form of the equation of the parabola? Or solve situational problems involving parabolas? Or were you able to demonstrate patience, determination, and critical thinking? I hope all of this were achieved in today's lesson. You're now ready to answer the drills on parabolas. Thank you and see you again.